According to the National Electrical Code, a disconnect is required on the primary side of a transformer. This requirement exists to ensure safety and provide a means to de-energize the transformer for maintenance, repairs, or in emergency situations. The NEC mandates this for several reasons, primarily focusing on personnel safety and equipment protection. The disconnect allows electricians and other qualified personnel to safely work on the transformer or downstream equipment without the risk of electrical shock or arc flash. The specific NEC section that addresses transformer disconnects can vary slightly depending on the voltage and size of the transformer, but generally Article 450 covers transformers, and related sections address disconnect requirements. These sections outline the conditions under which a disconnect is required, the types of disconnects that are acceptable, and the location requirements for the disconnect. Firstly, a disconnect must be readily accessible. This means that it should be easily reachable and not obstructed by other equipment or structures. The purpose of this requirement is to ensure that the disconnect can be quickly accessed in case of an emergency. Secondly, the disconnect must be rated appropriately for the voltage and current of the primary circuit. This ensures that the disconnect can safely interrupt the flow of electricity under normal and fault conditions. The amperage rating of the disconnect should be equal to or greater than the calculated primary current of the transformer. Thirdly, the disconnect must be lockable in the open position. This is a critical safety feature that allows personnel to lock out the disconnect while working on the transformer or downstream equipment. This prevents the disconnect from being accidentally closed, which could create a hazardous situation. There are several types of disconnects that are commonly used for transformer primary circuits, including fused disconnect switches, circuit breakers, and non-fused disconnect switches. Fused disconnect switches provide both overcurrent protection and a disconnecting means. They are typically used when overcurrent protection is not provided by another device upstream. Circuit breakers can also be used as disconnects, and they provide overcurrent protection as well. Circuit breakers are often preferred in situations where frequent switching is required. Non-fused disconnect switches provide a disconnecting means only and do not offer overcurrent protection. These are typically used when overcurrent protection is provided by another device upstream, such as a circuit breaker or fuses in the main distribution panel. The location of the primary disconnect is also important. The NEC generally requires the disconnect to be located within sight of the transformer or to be capable of being locked in the open position. If the disconnect is not within sight of the transformer, it must be lockable and labeled to indicate that it disconnects the transformer. This requirement helps to prevent accidental re-energization of the transformer while someone is working on it. In addition to the general requirements for transformer disconnects, there may be specific requirements that apply depending on the size and voltage of the transformer. For example, for larger transformers, the NEC may require additional disconnecting means or protective devices. It is important to consult the NEC and any applicable local codes to ensure that the installation meets all requirements. When selecting a disconnect for a transformer primary circuit, there are several factors to consider. Firstly, the voltage and current rating of the disconnect must be appropriate for the circuit. Secondly, the type of disconnect should be chosen based on the specific application and the need for overcurrent protection. Thirdly, the disconnect must be readily accessible and lockable. Fourthly, the disconnect should be installed in accordance with the NEC and any applicable local codes. To calculate the primary current of a transformer, you need to know the transformer's kilovolt-ampere rating and the primary voltage. The formula for calculating primary current is primary current equals kilovolt-amperes times 1000 divided by the primary voltage. For example, if you have a 100 kV transformer with a primary voltage of 480 volts, the primary current would be 100 times 1000 divided by 480, which equals 208.33 amps. Therefore, you would need to select a disconnect with an amperage rating of at least 208.33 amps. It is also important to consider any applicable derating factors when selecting a disconnect. Derating factors are used to account for the effects of ambient temperature, altitude, and other environmental conditions on the performance of the disconnect. The NEC provides tables and guidelines for directing disconnects under various conditions. In addition to the NEC requirements, there may be local codes or regulations that apply to transformer installations. It is important to check with the local electrical inspector or building department to determine if there are any additional requirements. Local codes may be more stringent than the NEC in some cases, and it is important to comply with all applicable requirements. Proper installation of a transformer primary disconnect is essential for ensuring the safety of personnel and equipment. The disconnect should be installed by a qualified electrician in accordance with the NEC and any applicable local codes. The electrician should verify that the disconnect is properly sized, rated, and installed before energizing the transformer. The electrician should also test the disconnect to ensure that it is functioning properly. Regular inspection and maintenance of transformer primary disconnects are also important. Disconnects should be inspected periodically for signs of damage, corrosion, or overheating. Any damaged or worn part should be replaced immediately. The disconnect should also be tested periodically to ensure that it is still functioning properly. Testing can be performed using a multimeter or other testing equipment. The disconnect should be opened and closed several times to ensure that it operates smoothly and that the contacts are making good electrical contact. Failing to install a primary disconnect on a transformer can have serious consequences. It can create a safety hazard for personnel working on the transformer or downstream equipment. It can also increase the risk of equipment damage due to electrical faults. In addition, failing to comply with the NEC and local codes can result in fines, penalties, and legal liability. For example, if an electrician is injured while working on a transformer that does not have a primary disconnect, the property owner or contractor could be held liable for the injuries. Similarly, if a fire is caused by an electrical fault in a transformer that does not have a primary disconnect, the property owner or contractor could be held liable for the damages. Therefore, it is essential to always install a primary disconnect on a transformer in accordance with the NEC and any applicable local codes. This will help to ensure the safety of personnel and equipment and will help to avoid potential legal liabilities. In summary, the NEC requires a disconnect on the primary side of a transformer for safety and maintenance purposes. The disconnect must be readily accessible, weighted appropriately for the voltage and current of the circuit, and lockable in the open position. There are several types of disconnects that can be used, including fused disconnect switches, circuit breakers, and non-fused disconnect switches. The location of the disconnect is also important, and it must be within sight of the transformer or capable of being locked in the open position. When selecting a disconnect, it is important to consider the voltage and current rating, the type of disconnect, and the accessibility and lockability of the disconnect. It is also important to consult the NEC and any applicable local codes to ensure that the installation meets all requirements. Proper installation, inspection, and maintenance of transformer primary disconnects are essential for ensuring the safety of personnel and equipment. Failing to install a primary disconnect can have serious consequences, including safety hazards, equipment damage, and legal liabilities. Always consult with a qualified electrician to ensure that transformer installations are done correctly and safely. This professional can help determine the specific requirements for your installation and ensure that all applicable codes and regulations are followed. Remember, safety is paramount when working with electrical equipment, and compliance with the NEC is crucial for protecting people and property from electrical hazards.